What's up, mathematicians? Today we are talking about word problems with the word of. In other words, I call it of word problems. And that usually means, so in word problems, generally, not always, but generally, the word of is an indication that you need to multiply. And I will give you some examples of how this can be used. So let's start off with a pizza. And I'm going to divide it into 4 parts. Let's pretend that these are perfectly equal parts. And I do a lot of examples with pizza. I don't know what that says about me, but anyway, we've got a pizza. And let's say I eat 3/4 of the pizza. Let me write that out. 3/4 of this one pizza. How much is that? Well, here's 1, 2, 3 out of 4 slices. So 3/4 of one pizza is 3/4. It's 3/4. However, this is where the word of is helpful when you're reading a word problem, when the problem is a little bit more complicated. Let's say that there are 2 pizzas. And let's say that they are divided into 4. Oh my gosh, that's not a good line. 4 equal pieces. Imagine that those are perfectly equal pieces. What if I told you that I ate 3/4 of 2 whole pizzas? 3/4 of 2 pizzas. How much pizza would that be? Well, this is an example of where the word of really means or indicates that you should multiply. And what do you multiply? Well, you take the 3/4, we're doing the portion part, 3/4 of, make it a multiplication symbol, and the number, the total, which is 2. So 3/4. So when we say 3/4 of 2 pizzas, we're going to change it to an expression 3/4 times 2, which is the same as 3/4 times 2 over 1. Because, as you probably know, any whole number over 1, when 1 is in the denominator, is itself. And so 3/4 times 1. And now we just multiply across. We multiply 3 times 2, and that is 6. And then we multiply 4 times 1, and that is 4. So 6 out of 4 pieces is my answer, which, let's just highlight it here. That's 1 piece, 2 piece, 3 pieces, 4 pieces, 5 pieces, 6 pieces. So 6/4. And as you can see, or as you might know, that is the same as 1.5, or let me put it here, equals 1 2/4, which is the same as 1 1/2. Let me give you another example of how of can be used in slightly more complicated problems. Let's erase all this here. I like to jog, and I like to run 5K races. 5K races are 5-kilometer races. And let's pretend I'm training for a 5-kilometer race. And I decided that I want to run, I can't run the full 5 kilometers, but I only can run 3/5. 3/5 of 5 kilometers as part of my training. Let's pretend I'm training today, and I don't want to run the whole thing, but I want to run 3/5 of the total race distance, which is 5 kilometers. Well, how many kilometers is that? If I want to know the answer, we have this of word problem. Again, we are going to change of to multiplication, that X right there. And then what are we going to do? Actually, you know what? I'm going to use a different color. Let's make it purple. Then you know what I'm going to do? I'm going to say 3/5 of 5 kilometers. And that equals 3/5 times 5 over 1, which then equals, and then we just multiply 3 times 5, which is 15. We multiply 5 times 1, which is 5. 15 fifths, which is also equal to 3 kilometers. So 3 fifths of 5 kilometers is 3 kilometers. And now let's go to a slightly more complicated word problem, or a multi-step word problem. This is actually a problem that I gave my students. Let me read it out. Audrey collects crystals and rocks. She has a total of 27 crystals and rocks. 1/3 of her collection is amethyst. 1/3 of her collection is pyrite, which is a type of rock. The rest of her collection is quartz. How many quartz rocks does Audrey have? So a lot of students, they get a little overwhelmed with word problems because there is a lot of information. There's a lot to process at once. And so one of the things that I tell my students is, and it might be a slightly unconventional approach, is I try to get them to figure out what operation might I need to do to solve this problem. Is it addition, subtraction, multiplication, division, a combination? So one thing I do is I usually reread the problem a few times, and then I look for important information. So we have Audrey. She collects crystals and rocks, and she's got a total of 27 crystals and rocks. And 1/3 of, so I see the word of, so I think there's going to be some multiplication involved. 1/3 of her collection is amethyst, 1/3 of her collection is pyrite, and the rest of her collection is quartz. I feel like that might involve addition or subtraction maybe. And for some students, and even for myself, I often like to create visuals to help me understand multi-step word problems. And by multi-step, I just mean it involves more than one step. So I'm going to start by just drawing a pile of rocks and crystals. Okay, that's not the best pile of rocks and crystals, but hopefully you get the idea. And the total is 27. So now in my head, and as a visual, I can kind of see 27 is the total number of rocks and crystals. And now the word problem says that 1/3 of this entire collection is amethyst. So amethyst is a very beautiful stone. Amethyst equals 1/3 of, which means multiply, of the total. The total is 27. Well, let's see if I need to know how many what number that is. What is 1/3 of 27? Let me get an answer. So amethysts make up 1/3 of 27 crystals and rocks. And I know when I see of, it really means multiply. And now I'm going to write out the this piece of the problem. 1/3 times 27 over 1, and that equals 27 over 3. 27 thirds is actually the same as 9. So there are 9, not going to have space there, 9 amethysts. 9 amethysts. So I've solved a bit of the problem, but now I need to figure out this part. It also says that 1/3 of her collection is pyrite. Well, I already see that 1/3 of the total is 9. So if 1/3 is amethyst, then 1/3 is of her collection is 9. So now I know that there are also 9 pyrite rocks. But now it's saying that the rest of the collection is quartz. And the question is really asking, how many quartz rocks does Audrey have? That is the question. Well, to figure this out, what I realize I need to do is I need to think about it. Well, I've got 27 total rocks and crystals. And I know I have 9 amethysts and 9 pyrite. So 9 plus 9 equals 18. So we've got 18 amethysts and pyrite, and I know the rest of the collection is quartz. So to answer this, I would do 27 minus 18, which equals 9. A lot of 9s in this situation. And that is my answer. There are 9 quarts in Audrey's collection. Let's go to this next problem that I also gave my students. It goes like this. William practiced math for 60 minutes yesterday. He spent 2/3 of his math practice time learning long division and the rest of the practice time on multiplication. How many minutes did he spend practicing multiplication? Oh boy, William practiced a lot of math yesterday, huh? Well, I'm looking at this word problem, and I think I need to reread it and really figure out what is some of the important information. Well, William practiced math for 60 minutes yesterday. Okay, that seems important. He spent 2/3 of his math practice time learning long division, and the rest of the practice time on multiplication. How many minutes? So we are staying in the unit of minutes. How many minutes did he spend practicing multiplication? Well, I see that there are these ofs here. So I already know I need to do some multiplication. That would make sense. So let's see. Let me write down the important information. He spent 60 total minutes practicing. He spent 2/3 of that time, so 2/3 of 60 minutes doing long division. So let's find out how many minutes that is. Well, 2/3 of 60 is the same as 2/3 times 60, or 60 over 1. And now let's multiply across. 2 times 60, that's 120. And then 3 times 1, that's 3. And I happen to know 120 over 3 equals 40 minutes. So now I know that William spent 40 minutes on long division, practicing long division. And he spent a total of 60 minutes practicing math. But that's not what the question is asking. It's saying he spent the rest of the time practicing multiplication. So the rest of the time would mean subtraction. So 60 is the total minus 40 minutes, which is how much he spent on long division. And what's the rest? It's 20. So he spent 20 minutes on multiplication. And notice that you always want to pay attention to the units that they're asking. What if they asked for how many hours did he spend practicing multiplication? Well, then, and we don't need to worry about this now, but just to let you know, then what we would do is we would say, okay, it's 20 minutes out of 60 minutes, because that's 1 hour. And one day you'll learn how to do this, but basically that is 1/3 of an hour. And that is something you'll learn about later, about converting units. But for now, suffice it to say, I did just want to throw that in there just to get you guys thinking. But we did those problems pretty fast. I hope that the main takeaway that you got is that there are times, and very often in word problems, where the word of signals that you need to use multiplication to solve the problem. And we will continue to work on this. Till next time, mathematicians.